Hi, this is Mr. Max with Sun Koffa Mathematics. So today I'm doing kinematics speed time graphs. So kinematics, as we know, is the study of motion, all right? So when we draw the speed time graph, the gradient gives us the acceleration or the deceleration or retardation of the object. And obviously, whenever you are drawing it on a graph, the vertical distance, the y-axis, that is where you are going to indicate your speed. And the horizontal distance, okay, this is where you're going to indicate your time. All right. So very important that you get that right. The speed is either given in kilometers per hour or meters per second, and then the time is either given to in hours or seconds or minutes, okay, depending on the unit that you are dealing with. Now the acceleration, obviously, as you can see on this representation, it is obviously that particular graph that goes upwards like that, okay. And then the constant speed is where the gradient is equal to 0, and the deceleration D there tells you you are going down, okay? That's the retardation. So what you have here with a speed time graph is the area now. The area that you have here under, that is the distance, and that is how we calculate distance. Okay, so one of the things that I always advise students to do is when you know how to calculate the gradient, because the gradient is the vertical distance, in this particular case the speed, always divided by the horizontal distance, in this particular instance the time. Whenever you know how to find the gradient, then you will ask a question on find the acceleration or find the deceleration or the constant speed, then you just use the formula for the gradient, which is that vertical distance. In this case, in the y-axis is the speed divided by the horizontal distance, in this case in the x-axis, which is the time. Right, so that actually also tells you the rate of change of speed. Okay, so remember, whenever you are asked to calculate the acceleration or deceleration, all right, you obviously need to think about the gradient. Okay. So let me just clean this up and clean it up a bit. What we refer to, how does it get to meters per second squared? So we know that gradient is speed divided by time. All right. So that gradient there, so the speed, let's suppose we work with meters per second. So meters per second is nothing but meters divided by second. So meters per second is the same thing as meters over second, and that is what I have here. Okay, and when you divide it by the time, so when you divide it by the time by second, whenever you divide something, that's the same then as multiplying. You can change this division here to a multiplication, and when you do that, you are dealing basically with something like meters per second times 1 over second. So what you have here is meters on top, and here you have second square. So this second square can be rewritten as meters per second square. That is just another way of writing it. Okay, so that is what I'm planning to show by how you get to that meters per second. So you do not get confused as to where is the meters per second basically coming from. Okay, so it's very important that you remember that, and the unit for speed is meters. For the gradient here, or the acceleration or the deceleration, is meters per second squared. Okay, maybe something else worth remembering, when we are talking about average speed, we take the total distance divided by total time. It's quite useful to have this formula. When we talk about the area refers to that distance, all right? So that distance there is the speed times time. So when you can find the speed multiplied by the time, that's going to give you the area, which is the same as the distance. When you want to find the speed, then, okay, we then obviously say the acceleration or the deceleration times the time. All right. So when we're talking about speed, we are finding acceleration or the deceleration times the time. When we want to find the acceleration or the deceleration, we take the speed divided by the time. When we want to find time, you say speed divided by either the acceleration or deceleration. Okay? So when you want to find the speed here, you can take the area, you divide it by the time. When you want the time, take the area divided by the speed. This is worth remembering, okay, when we are dealing with this particular question. So I'm going to do 5 questions here, all right, and I suggest you pay attention to each one of them, and we're going to calculate how, or do different things from calculating the area to finding the distance, for example, or finding the acceleration or deceleration, okay, of an object. All right, so let me get right in there. So my very first question says that a car starts from rest, okay? And this the graph here shows the first 7 seconds. So as you can see from this graph, the first 2 seconds, okay, the speed of the car was 10 meters per second. And then it's accelerated again, all right, by a further, 2 meters per second. That it did that in 5 seconds. The way I get 5 is 7 minus 2. All right. So the first question is, you're supposed to calculate the acceleration between 2 and 7 seconds. It means we have to find this particular acceleration, that gradient there, that rate of change. And to find that rate of change, it's going to be this distance here. And this is where it becomes a little bit more tricky for you. It's this distance here, which in particular will be 14 minus 10, okay, and you divide it obviously by this distance here, which is the 7 minus 2, all right, that gives you the 5. All right, so we want to find that acceleration. We then find our answer as the 10 here, all right, which is the 4 here, which we get from subtracting that, so that is the distance here, divided by 5. So that gives you 0.8 meters per second square. Remember, we are finding acceleration. When you calculate acceleration, that obviously means you are going to work with your meters per second square. Okay, all right, so there's a second part to this question, all right, that we are going to have a look at, and that second part will deal with finding the area or the distance that the car covered in the first 7 seconds. So let's have a look at that part. Right, so the total distance or the distance traveled by the car, so let me bring back my graph. So the way we find it is we find the area here. So I'm going to divide it into 3 little shapes. So the first one, all right, we want to find the area, which is the same as finding the distance traveled, okay? So it's speed times time. So the way you find, I can divide it into small triangles and rectangles. So this is, for example, triangle 1. And to find the area of that triangle, you say a half times base times the height, which is 10. Then I can maybe have my second one there. It's also a triangle, okay? So it's going to be a half times, remember this is 5 here, and this here is 4, all right? Because it's like 14 minus 10, all right? So that is 10 meters there and 10 meters here. And then maybe this particular rectangle here, and its area is very straightforward. It's 5 for this distance times the 10. Right, so the total distance traveled, you just add those areas, okay, and that gives you 70 meters, and that is how you find distance whenever you're dealing with a speed time graph. So I'm going to look at a second question. Right, so the second question here says a cyclist, he cycles 4 meters per second. After 3.5 seconds, he starts to decelerate. All right, slows down. Can you see that? All right, after 3.5 minutes, seconds, or rather, he slows down, decelerates. Okay, retardation. And then for a further 2.5, that is 2.5. This, all right. Then he stops, obviously. Right. So we are supposed to calculate the constant deceleration, that retardation that you see there. So we are supposed to calculate that. Now remember what I said. This is a very straightforward concept. You just basically have to find your gradient, which is obviously going to be this distance here. All right. Divide that by this distance here. All right, so that's how you find that particular answer. Right, so we can therefore just calculate it, and it brings us nothing to the 4 meters per second here divided by the 2.5 meters, 2.5 seconds here. That gives us 1.6 meters per second squared. Right, so there is the second question. Now they are asking us to calculate the total distance that is traveled by the cyclist in these first 6 seconds. So what we're going to do is we're going to also then find the area. Okay, so I can have here a rectangle, and the area here of this rectangle is going to be 4 times 3.5, which gives me 14. And I'm going to have that particular triangle there. Okay, so that area there is going to be 5 half times base. The base is 2.5 and the height is 4. You could also make it is a trapezium. Whatever you do, you add the 14 plus 5, you should get 19 meters, and that is the distance traveled. Okay, that's how you find the distance when you deal, again, as I said, with a speed time graph. Question 3. So here we have got a person who does a charity walk. Well, it's an oxymoron, charity walk, fun walk, all depends. But the question says he walked 43.4 kilometers. That's a very long distance to walk. And he had his average speed that he had done this particular distance was about 2.8 kilometers per hour. So you have got the speed, you have got the distance. So we are looking for the time. How long did he walk? So remember how you find time. Time is simply found by taking the distance divided by the speed. All right, and if you take this distance 43.4 and you divide it by 2.8, you're going to get 15.5 hours, which is about 15 hours and 30 minutes. This is a very long way to walk, though. All right, long time that it does that. Right, but now it says here he did this at night, so that was 10 minutes to 9. Okay, that means the next day he's going to finish, because remember it took him 15 and a half hours. So we want to find what time the next day did he finish that. So first what I do is I change 15.5 hours to 15 hours and 30 minutes. Okay, from decimal to hours and minutes. And I have a method where I just add. Okay, so I add the time. Right, so I get 35.80. Now I'm going to subtract 24 hours from it. Okay, because it goes overnight. So when I subtract 24 hours from that, now remember, I get 11.80, but there's no such thing as 11 o'clock and 80 minutes. So 80 minutes is already more than an hour. So essentially what I'm doing here is I am adding that 1 hour there, okay, after I do the subtraction here. So that should definitely give me the next morning or the next day, 20 minutes past 12, all right? That is the next day when he finished walking. So there are other ways that you can find this as well. It's totally up to you, but you should be able to get to the answer of 20 minutes past 12. That is the time he finished his walk the very next day. My fourth question here is a straightforward question. Says a car accelerates steadily from rest to a speed of 20 meters per second in 15 seconds. Now, what you can do before you are going to answer the question here, it's perhaps worthwhile to know what does one little block represent. So I have got 1, 2, 3, 4, 5. So I've got 5 here. So one block represents in the x-axis 5 seconds. All right. So this is going to be 5. That is going to be 10 here. 15. All right, and 20. So now you know where 15 is because it says that in the first 15 seconds. All right. Perhaps you also want to know on the y-axis for the speed. All right. You also have got 4. What does one little square represent? Well, it also represents 5 meters per second. It's always something that you should try to do before you attempt to answer questions. Right, so what they are saying is we are supposed to complete the grid. So you have got an incomplete grid that you're supposed to complete. So very straightforward from the first 15 seconds, and then he stops. All right, covered 20 meters per second. That was his speed. So that is the particular line that they are looking for. Okay, So the second part, now you're supposed to calculate the acceleration. Remember, acceleration is gradient, okay? Vertical distance divided by horizontal distance. Now, when I do that, obviously I'm going to bring my 15 back here because now it's only from 0 to 15. So it's going to be 20 meters per second. Divide that by 15 seconds. So I get about 1.33 meters per square seconds. All right, so basically you have got a recurring decimal there, which you can go ahead and also then write as perhaps 4/3 meters per second squared. That is also actually the correct way you can do that. All right, so this is a very straightforward question. It depends on you using the gradient. Remember, gradient, that's how you are calculating acceleration. Then the B part, now you're supposed to calculate the distance traveled in these 15 seconds. So it's nothing but this area under this line, okay? So that is a rectangle there, so, I mean a triangle rather. So I can definitely calculate the area of a triangle, which is a half times the base, which is 15, times the height, which is 20. 150 meters was covered by this car, right, during the first 15 seconds. 150 meters. Okay, I hope that is straightforward. So I'm going to do a fifth question on the same topic. Right, let's do question 5. So question 5, you must be a bit very careful when you read this question. So it says that Robert jumps from a balloon. He falls faster and faster, and you can see here, okay, so the way the graph is drawn, it looks like something is going up, but this is an object that is falling, so he's jumping from a balloon. Okay, so it doesn't go up, it goes down. All right, and then when he reaches 3 seconds here, he opens his parachute. So the moment he opens his parachute, his speed decreases the speed at which he falls. Okay, for the next 9 seconds. So the 9 seconds is obviously when you add here the 3 plus 9, then you get to your 12. Okay, so that's for the next 9 seconds here is what we are saying. Then something happens here. All right, then his speed remains constant, as you can see. All right, later on you'll see whatever that constant speed is. So that is how that particular question or instruction is. So let us see what is it that they are asking us to do. So they are saying that for the first 3 seconds only, okay, you're supposed to calculate this acceleration. Now that is very straightforward. Acceleration is that 27 divided by 3. So it's basically that vertical distance of 27 divided by 3. All right, so that is 9 meters per second squared. That is his acceleration that you are supposed to calculate. And also for the first 3 seconds, so let me bring in like a sort of a triangle here where I represent this area here. They are saying we're supposed to find the distance. So how do you find the distance in speed time graph? You then multiply, or you find the area under the graph. The area here is a triangle, and the formula is a half times base times height, which gives you 40.5 meters. And that's how you find this particular answer to this question. Remember, it says for the first 3 seconds. Okay, so these ones are very straightforward. Make sure that you don't make the mistake of calculating for 12 seconds. Okay. Right, the B part of this question, and this part of this question you are supposed to read very well. You're supposed to be a bit very careful. All right, there is a hint there, but we're going to try to read it step by step. So it says that the total distance Robert falls in the first 12 seconds is 112 meters. And this is what you need to understand, all right? The area, here we already know, okay, we already know from our previous work, this was something like 40.5, okay? But now there's something else here, all right? So now we're talking about the 40.5, which is here, and also this particular part. So this particular distance that he was doing there was 112 meters. But now you must understand that they're saying after that, his constant speed after that was 2 meters. So then his speed, as you can see, the way the line is, was 2 meters per second, okay? Maybe that is a little bit, as they say, not written so nicely, but let me just explain again. So here you have got the speed, his speed after that was constant, right? So his speed after that was nothing but 2 meters per second. Now, they are asking you to calculate it in minutes and seconds, the total time the balloon was 1,000 meters, if the balloon was 1,000 meters above the ground. So when he's here at 12, then there is still a certain height that he has above ground. All right, because it covered already, it fell already 112. So that means he is now 888 meters above ground. That qualifies as the distance. Okay. Now, when you have the distance, right? You have the distance here, which is 888. All right. You also have the speed, which is the 2 meters per second. Okay. The distance is meters. So when you are supposed to find the time, so I'm now only calculating time for after what happens to the 12 seconds, okay? So the time would be that 888 rather, all right, meters, divide that by 2 meters per second. So this is going to give me 444 seconds, all right? So that is his time now from 12 all the way up to that, okay? But you must understand, we're looking for his total time. So when you find the total time, you have to take the 444 seconds, then you add it to the first 12 seconds that you already covered. All right, so that gives you 456 seconds. And your job now from here would be to change this 456 seconds that you are getting here. You change it to minutes and also to seconds. Okay, so that is basically how we are going to deal with this particular question. All right, so I'm going to bring up the solutions as I have done them step by step so that you can get an idea. All right, so you already have an overview as to how you're supposed to deal and find this particular problem or the question or the answer to this. Remember, we're looking for the total time, and we're not looking for the time after the 12 seconds, but a total time, which means we have to consider the 12 seconds as well. It must be included because we know that, in the first 12 seconds, we know the distance that was covered in the first 12 seconds was 112 meters. All right, so we need to find the other time. So that 12 seconds must be added. That is why the word total time, the total is bolded for you. So after 12 seconds, as I said, he is now 888 meters above ground. Okay, and also his speed now is constant at 2 meters per second. All right, so that's the distance. So what we do is when we divide, because to find the time, you take that area, which is the distance, all right, because this area is given as the distance, over speed, that's 888 meters divided by 2 meters per second, that gives you 444 seconds, all right, but this is after the 12 seconds. All right, so let me just quickly then just write 444 seconds in minutes and also in seconds. So that gives you 7 minutes and 24 seconds if you do that. Okay, so this was only the time after the when the speed was 2 meters per second, but then the speed that he fell was different. So we need to find also, we know what that time was during that part when the speed was not the same. So in order for us to find the total time, then we must take the 7 meters and 24 seconds and we should add it to the 12 seconds. That's going to give us a total time of 7 minutes and 36 seconds. Okay, so please go back to these five questions I have done and try to see if you can also do them on your own. Pause the video and then maybe you can attempt to do further questions on your own on the topic of speed time graphs.